Next, graphical representation, bar charts and histograms. Graphical representation is a powerful tool for conveying data visually. Bar charts and histograms are two common methods used to display and analyze data. They are crucial in various fields including statistics, research and data analysis. Then bar chart. A bar chart is a graphical representation of data that uses rectangular bars of varying lengths to represent different categories or groups. Each bar's length corresponds to the value or frequency of the category it represents. Bar charts are typically used to display categorical data where the categories are discrete and separate. Then characteristics of bar charts. Categorical data. Bar charts are suitable for displaying data in categories or groups. Examples include the distribution of car types, product sales by category, or the frequency of student grades. Then two axes. A bar chart typically has two axes. The horizontal axis, x-axis, represents the categories and the vertical axis, y-axis, represents the values or frequencies. Then non-continuous. A categories in a brief bar chart are non-continuous and have no inherent order or numerical meaning. Then uses of bar charts. Comparison. Bar charts are used to compare different categories or groups. They allow for a quick visual assessment of which category has the highest or lowest values. Then frequency distribution. Bar charts are often used to display the frequency distribution of categorical data. Histogram. A histogram is a graphical representation of data that uses contiguous adjacent rectangular bars to represent the distribution of continuous data over a range or interval. Unlike bar charts, histograms are used for continuous data and the bars are continuous, indicating that there are no gaps in between them. Characteristics of histogram. Continuous data. Histograms are used to display continuous data such as age, weight, or time intervals. Then two axes. Like bar charts, histograms have two axes. The horizontal axis represents the data range, often called the bins or intervals, and the vertical axis represents the frequency or density. Then contiguous bars. In a histogram, the bars are contiguous. They represent the frequency or density of data within specific intervals. The use of histograms. Distribution of data. Histograms are essential for displaying the distribution of continuous data. They allow for visualizing the data's shape, central tendency, and spread. Then frequency distribution. Histograms provide a visual representation of how data is distinguished within intervals or bins. Then construction of bar charts and histograms. Bar charts. To create a bar chart, plot each category on the x-axis and the corresponding values of frequency are on the y-axis. Draw bars for each category, ensuring that they do not touch or overlap. Then histogram. To construct a histogram, create intervals or bins along the x-axis to represent the data's range. Count the frequency or density of data points within each bin and create contiguous bars to represent this frequency. The bars' heights correspond to the frequency or density. Graphical representation, including bar charts and histograms, provide a clear and visual way to understand data. They are especially valuable in making data-driven decisions, conveying complex information, and identifying patterns in data. Bar charts and histograms are versatile tools for displaying and analyzing data. Then pie chart and table chart, line chart. Graphical representation is a powerful tool for visualizing different data and patterns. Pie charts, table charts, and line charts are widely used in data analysis, research, and decision making, each serving specific purposes. Pie chart. A pie chart is a circular chart divided into slices resembling a pie. Each slice represents a proportion or percentage of a whole. Pie charts are used to illustrate the relative sizes of different categories within a data set. So, characteristics of pie charts. Percentage representation. Pie charts display data as percentages of the whole. Each slice represents a proportion of the total that corresponds to a specific category. Then circular. Pie charts are circular and represent the whole. The entire circle corresponds to 100% of the data. Uses of pie chart. Proportion display. Pie charts are used to show how a whole is divided into various parts. They are ideal for visualizing the comparison of a whole, such as market share, budget allocation, or the distribution of resources. Comparing parts to whole. Pie charts make it easy to compare each category's share to the entire data set. Then table chart. A table chart, also known as a data table, is a structured representation of a data organized into rows and columns. It is used to display detailed information and is highly suitable for presenting data that can be easily compared and referenced. And characteristics of table charts. Structured. Data in a table chart is represented in rows and columns, allowing for easy organization and reference. Numeric and texture. Table charts can contain both numeric data and descriptive text. Uses of table charts. Data representation. Table charts are used for presenting detailed data that require numeric precision and context, such as financial reports, survey responses, and scientific data. Comparisons. Table charts enable side-to-side comparison of values in different rows and columns, making them suitable for analytical purposes. Then line chart. A line chart is a graphical representation of data that uses lines to connect data points. It is used to illustrate trends, changes over time, and the relationship between variables. Characteristics of line charts. Time series data. Line charts are commonly used to display data over time with time represented on the x-axis. Then continuous data. They are suitable for showing the relationship between continuous variables. Then connected data points. Data points are connected by lines, providing a visual representation of the data's trend. Then uses of line charts. Trend analysis. Line charts are essential for identifying trends and patterns in data over time, such as stock prices, weather data, and population growth. Comparative analysis. Line charts enable the comparison of trends between multiple variables, making them useful for analyzing relationships. Significance. Graphical representation include pie charts, table charts, and line charts, enhance data communication and understanding. They are valuable tools for conveying complex information, identifying trends, and supporting data-driven decisions. Then mapping of data. Mapping of data, often referred to as data mapping, is a fundamental concept in data management, database design, and information technology. Data mapping. Data mapping is a process of defining how data from one source is transformed and represented when it is moved to a target system or data structure. It involves creating a link between the sources and target data elements, specifying how the data should be converted, transformed, and loaded. So, importance of data mapping. Data integration. Data mapping is crucial for data integration, whereas data from various sources, formats, and structures are combined into a unified format. This integration allows for comprehensive analysis and reporting. Then data migration. In data migration projects, where data is transferred from one system to another, from an old database to a new one, data mapping ensures that data remains accurate and usable. Then data transformation. Data mapping facilitates the transformation of data into a standardized format, making it suitable for analysis and reporting. Steps in data mapping. Source and target identification. Identifying the source data, which can come from database, files, or external systems. Identify the target data, including the data structure and format in the designation system. Data element matching. Match each data element from the source to its corresponding element in the target. This involves identifying which source elements map into which target elements. Transformation rules. Specify transformation rules to convert the data. This includes data type conversion, data cleaning, and any necessary calculations. Data mapping document. Create a data mapping document that describes source to target mapping, transformation rules, and any business logic involved. Then testing. Conduct testing to ensure that the mapping and transformation process work correctly. This involves data profiling, validation, and reconciliation. Data mapping tools. Data mapping is often done using specialized tools and software which streamline the process and provide visual representation of the mappings. Common data mapping tools include Informatica Power Center, Talent, and Apache Nifi. Significance of data mapping. Data quality. Data mapping ensures that data quality is maintained during transformations, preventing data errors and inconsistencies. And data integration. It is vital for integrating data from diverse sources, enabling organizations to gain a holistic view of their data. Then data migration. In data migration projects, data mapping ensures that data is transferred accurately and that it remains usable in the new system. Then data governance. Data mapping is a fundamental aspect of data governance, helping organizations maintain control over their data assets. Data mapping is a critical process in the management, integration, and migration of data. It ensures that data remains accurate, consistent, and usable as it moves from source to target systems. Understanding data mapping is essential for professionals in fields like data management, database administration, and information technology, making it a crucial topic. Then data interpretation. Data interpretation is the process of making sense of data by analyzing, summarizing, and drawing meaningful conclusions from it. It is a crucial skill in various fields, including statistics, business research, and decision making. Types of data. Quantitative data. Numerical data that can be measured and expressed in terms of quantity. It includes data like age, income, and temperature. Qualitative data. Non-numeric data that describes qualities or characteristics. Examples are gender, color, and job titles. Data sources. Data for interpretation can come from diverse sources, including surveys, experiments, observations, databases, and external data providers. The source and quality of data play a significant role in interpretation. Steps in data interpretation. Data collection. The initial step involves gathering relevant data from various sources. The data should be representative of the problem or phenomenon under study. Then data cleaning. Data may contain errors, missing values, or outliers. Cleaning data involves identifying and correcting these issues to ensure data accurately. Then data exploration. Data exploration includes techniques like data visualization, summary statistics, and frequency distributions to gain an initial understanding of data's characteristics. Then data analysis. Data analysis involves using statistical methods, mathematical models, or software tools to uncover patterns, relationships, and insights within the data. Then interpretation. The final step is the interpretation of the results of the data analysis. It involves drawing meaningful conclusions, making inference, and providing insights into the problem at hand. Techniques in data interpretation. Descriptive statistics. Descriptive statistics like mean, median, mode, standard deviation, and variance help summarize and describe data. Inferential statistics. Inferential statistics involve making inferences about a population based on a sample. Techniques include hypothesis testing, confidence intervals, and regression analysis. And data visualization. Data can be represented graphically using techniques like bar charts, histograms, line charts, scatter plots, and pie charts, making trends and patterns easier to interpret. Then qualitative analysis. Qualitative data may be analyzed through thematic analysis, content analysis, and narrative interpretation. Significance of data interpretation. Decision making. Data interpretation is crucial for making informed decisions in various fields, from business strategies to healthcare. Problem solving. It is essential for understanding and solving complex problems by uncovering insights and patterns. Then research. Data interpretation is fundamental to the research process, allowing researchers to test hypotheses and draw conclusions. Challenges in data interpretation. Data bias. Biased data can lead to erroneous interpretations. Data overload. The vast amount of data available today can make interpretation overwhelming. Data complexity. Some data sets are highly complex and may require advanced analytical techniques. Data interpretation is a crucial skill. Then data and governance. Data and governance are interconnected in a digital age where data has become a valuable asset and an integral part of government operations and public administration. Data and governance. Data as a strategic asset. Data is a strategic asset for governments, offering insights into societal trends, public services, and administrative efficiency. It helps governments make informed decisions and formulate evidence-based policies. Then types of government data. Open data. Governments are increasingly adopting open data policies, making non-sensitive data accessible to the public. This transparency fosters public trust and encourages innovation. Big data analytics is employed to process massive database, enabling governments to detect trends, predict future needs, and improve service delivery. Then geospatial data. Geospatial data, including maps and satellite imagery, is used for urban planning, disaster management, and resource allocation. Then data governance. Data governance is a framework that encompasses the policies, processes, and controls that ensure data quality, data management, data privacy, and data security within the organization, including government bodies. So, components of data governance: data quality, data management, data privacy, data security, and data stewardship. Appointing individuals responsible for data oversight and ensuring adherence to government policies. The rules include policy development, public service improvement, accountability and transparency, then emergency response, data privacy and security. Then data libraries will be there, ethical concerns are also there. Significance include efficiency and accountability, innovation, citizen engagement. So these are some important points related to data and governance.